first of all, I'd like to thank you for coming here, spending your time with me, learning new things. So yeah, also like to thank all the sponsors. Without them, this is not possible. Every one of you. So this is about TurboPack and Rspack. The title seems different than what you see right now on the screen. Because I want to add another JavaScript bundler written in Rust. So that's gonna be like better version of what it used to be, since there are now two things here that I'll be discussing. So a little bit about me. I'm originally from Manila, Philippines. Been living and working now in Oslo, Norway for 4 years. I'm a Microsoft MVP working for Inmeta, which is an IT consultancy. And I've written some books in 2011. That was my first book, and another one after a year, and then another one after a year. So full stack, Spring Boot, Angular, ASP.NET Core, Vue.js, and then another one, TypeScript, React for enterprise application. But anyways, so much for that. Let's get it on. So you see here a car design that shows you different pieces that were put together to build this car, right? So similarly in software applications, these pieces are called modules. So you can also say that in, for example, in React or React components, these are the building blocks of React application, right? Creating modules to build software or a car gives benefits like, first is isolation. So it allows people to work individually on the car or on the application, without delaying someone. Another one is composability. So clear boundaries for each individual component. They're able to compose each piece together to create a fully functioning feature, right? Another one, reusability. Reusability can reuse the same components. For example, in this car, that would be the wiper, the wheels, the seats, etc. Right? Another one, another benefit, organization. So the effect of each individual piece having clear boundaries for how they interact with each other benefits us. So how do we do modularize, or how we modularize our code before? First, or in the beginning, there's this IFI, or immediately invoke function expression. It mimics a module scope. It hides variables, self-contained, etc., and it helps us create module pattern back in the day, right? And in this example of IFI, the X variable is not visible outside of the IFI, so trying to log it outside of the IFI function results in a reference error. The next is, after IFI, CommonJS, so built for Node.js originally and synchronous. And then after CommonJS, we have this asynchronous module definition, which is AMD. AMD, example of AMD is required.js. So AMD fixes dependency resolution and pollution of global scope. We use this AMD and CommonJS to share libraries through NPM packages. So this is the start. So how do we use CommonJS in the browser if it's built for Node.js and it's synchronous? We have this for a while, Browserify. So Browserify is made to support CommonJS in browsers. It is a module bundler that needs, or that reads all requires and module exports and bundle all JS files into one JS file, right? Or bundle.js that you often see. Browserify needs gulp and grunt though. or these are task runners, by the way, to run. So there's a little bit of cons about there. Then after Browserify, we have Webpack. This is a module bundler, right, that can do things that Browserify can do, such as detect the code you don't use to exclude it while combining files, serialize the code and load it only when it's necessary, right? Monitor file alterations, and of course, it has a transpiler, which transpile code to ES5 or other things. And another one is it can concatenate multiple files together in a single bundle for the browser. The problem that Webpack has, it's the process becomes increasingly slowly as your application grows. And you would know that, you would notice that if you have a large React application or let's say Angular application, the HMR or the hot modular replacement takes 5 seconds, 4 seconds, 10 seconds if you have a shitty machine. Oops, I'm not sure if that's possible. But yeah, if you have not so good Windows or MacBook, you know the drift. So let's go here. First will be TurboPack, written in Rust by the creators of Webpack and Next.js at Vercel. So this is the new one. So TurboPack delivers a swift and versatile development experience for applications in any scale. It doesn't matter how large the application is. So the idea is make the HMR as fast as it could, and it shouldn't change, depending on how large the application. It doesn't matter how big, as long as it stays like in a milliseconds. So that's the idea. That's the goal. But yeah, why TurboPack again? Aside from HMR, incremental by design. So building once is enough work. Once TurboPack performs a task, it never does it again. It's like there's a built-in cache within it. Ecosystem friendly, so you get out-of-the-box support for TypeScript, JSX, CSS, CSS modules, WebAssembly, etc. And lightning-fast HMR, which I already mentioned. Hot module replacement, right? Another one, React Server Components. So support for RSC, which is the future of React. And simultaneous multiple environment targets. So you can build and optimize for multiple environments together: browser, server, edge SSR, React Server Components. And Next.js support. Let's move there, because it's being built under Vercel. Of course, it's just not surprising that by default it supports Next.js. So why replace Webpack, aside from it's getting slower as your application gets larger? So Webpack was created 10 years ago, retains its dated architecture despite web development significant growth. Another one here. Plugins, it can do anything. Backward compatible, so large changes are hard to do. There's another one. And cache invalidation, too sensitive. Incremental builds. Cache lookup helps skip redundant work, but with many modules, it can lead to considerable cache lookup costs. So these are the main problems in Webpack. Now let's move on to the architecture of TurboPack. So Vercel created a layering system under Rust as the base. So the base of this TurboPack bundler will be the Rust programming language. So why Rust? Rust offers parallelism. more control of memory allocation without being painful as C++, and it's all about the security, right? But it's more challenging to write than JavaScript. So let's face it, JavaScript is easier, especially if you already know JavaScript. But to encourage plug-in development, Vercel supports both JavaScript and Rust for plug-in interfaces. So anyone or all developers can start with JavaScript and then port it to Rust afterward. So another one here, next layer, Turbo Engine. So a core engine for common tasks like caching, invalidation, and incremental builds. Vercel is also using SWC. This is a modern transpiler built in Rust that replaces Babel. So instead of the Vercel team creating their own transpiler, they just use this SWC, by the way. It's an open source transpiler, and it's also written in Rust. So that's a big time saving for them because they get to use someone else's work rather than them creating it alone. And then the TurboPack itself. So a bundler handling CSS, static assets, WASM, images, fonts, and more leveraging of the SWC. And then the support for Next.js and other frameworks that can use TurboPack as a bundler. But right now, it's just Next.js. But the plan is to support React, Vue.js, Svelte, Angular, and so on. So why TurboPack is so fast? Let's look at here. So TurboPack's impressive speed is attributed to incremental computation engine. So in a typical bundler here, the process, you see here, the bundler, the process involves reading the files. You can see here, both of these, and then bundling them. I hope you can see here, my mouse. And then concatenating them, see here, and then performing multiple tasks to create this full bundle, right? However, TurboPack takes it in a different approach by keeping track of the inputs or caching it and outputs of each function. So during the first run, it reads, bundles, concatenates the files, and remembers all the outputs. On the subsequent run, or subsequent runs, if a specific file such as SDK.ts, for example, this one, let's say it was modified, TurboPack only needs to redo the steps related to that file, here, as you can see here, and it doesn't need to read or bundle the unchanged files like API.ts. So this incremental computation and the native speed of Rust are responsible for TurboPack's speed performance. So it's just going to rebundle all the files that have been changed. It doesn't rebundle everything, right? So interestingly, the Turbo engine itself is not involved in the bundling process. Its main function is to save, again, the results of the function, the output, which is like a cache. So that's the architecture of TurboPack. Getting started with TurboPack, just have to run the command npx create next app with TurboPack as a template. And then you would notice after running this npx script that inside the JSON, the package.json, you will see this dev script here with the flag Next.js dev with the flag -- turbo. So meaning it's going to use TurboPack as the bundler for your Next.js application. Just a warning here, though, in TurboPack, if you're building application using RSC or React Server components, TurboPack doesn't support it yet, at least this time. By the way, let's see a month from now or 2 months from now. But right now, you would see some errors or warnings in your terminal that, sorry, TurboPack doesn't support RSC yet. So that's TurboPack. There's no like demo I can show you because this is just a bundler. If I bundle the Next.js application, it will be the same application that you would see if I demo a Webpack, right? So let's just move to another JavaScript bundler written in Rust, which is Rspack. So ByteDance and Valor Software introduced Rspack to the open source community. And if you haven't heard ByteDance, that's the tech giant behind popular platforms such as TikTok and Douyin. And they open source. They're actually dog fooding their own source code, their bundler. So this is what they're using in that platform, Rspack. So let's check it out. Why is it so, getting this popularity? So fast startup, that's one, same as TurboPack. Pretty much the same. Lightning HMR. So it's the same also. So basically the same. And I will show you later what it makes the difference between TurboPack and Rspack. But if you're gonna ask me, performance, almost the same. And the features, right? They support TypeScript out of the box, Lightning fast HMR. But let's talk about Webpack compatibility. So if you have written React application with Webpack configuration and you know how to configure Webpack, that skill won't go away if you try Rspack. Why? Because Rspack supports Webpack configuration out of the box. But not all. By the way, you cannot just copy everything in your Webpack configuration and expect that it will work in Rspack. They have 100% compatibility support, but there are still pieces there that it's still at the work. So yeah, this is the main difference between the two. In TurboPack, it's not using Webpack, but Rspack, it's fully compatible and you can use this. Okay, aside from that, batteries included. So again, TypeScript, JSX, CSS modules out of the box, it works. Production optimizations, so it optimizes caches. So same thing as in TurboPack. And this is when they release it, when they release a stable version of Rspack, it's framework agnostic right away. So you can use it in Vue.js and React as of today. So how do you get started with Rspack? npm create Rspack at latest to get the latest version. And you will see in the package.json, you have this script dev Rspack serve. So it will just run your React application. And just to show you a little piece of what I'm saying earlier, Webpack compatibility is when you open up the boilerplate, the source code or the repo that you just generated from Rspack boilerplate generator, you would see this Rspack config. I'm not sure you see it there, .js that it's similar, but actually it's the same configuration that you would do in Webpack. So, stable and battle-tested bundler. Let's say TurboPack, it's still in beta, so I wouldn't recommend using that in production. What about Rspack? Let's say yes and no. Yes, it works for TikTok, but I wouldn't say also, let's say, it's too early to tell because Vite, JavaScript bundler, is going strong and a lot of support's being done in Vite. And what I can recommend is if you're going to write application today, and thinking of replacing Webpack with much faster bundler, I would highly recommend Vite. Vite has been, for 3 years, I think, since 2019, 2020. So again, this is just an opinion from me. Choosing between TurboPack, Rspack, I wouldn't recommend it. I would go with Vite for, it's battle tested, a lot of support. You can do a lot of things with Vite, and they're solving the same issue that developers are experiencing, which is lagging in seeing the changes when you change something in the front end, like, for example, CSS or JavaScript, and then expecting that it will show up on the screen in a few seconds. Well, this bundler does that perfectly, and it doesn't matter also how big is the application. You get this O of 1, in speed, in terms of speed, that constantly, it doesn't matter how big the application. We have this constant number of how fast the HMR will be. So, just to summarize, TurboPack and Rspack, they're both Rust-based bundlers, lightning fast HMR. Rspack has Webpack compatibility, while TurboPack does not have. TurboPack and Rspack provide improved DX or development experience or developer experience. And Vite is the most mature bundler as of today, which is not written in JavaScript. So, resources. I would recommend going to these links, turbo.build/pack, rspack.dev, and vite.js.dev to get this, a better DX when you're writing application, modern application as today. So that's it. Thank you for listening for this quick introduction about Rspack and TurboPack and why you should use these bundlers here for giving you better development experience. Thank you.